I'm contestant Gong, and this is the video entry I submitted to the competition. Model of optimization: the low-carbon practicing of rural dwelling at Beijing-Hangzhou Grand Canal SuQian section, China. Welcome to our exploration of optimizing low-carbon practices in rural dwellings along the SuQian section of the historic Beijing-Hangzhou Grand Canal. In the quest for a more sustainable future, rural areas play a crucial role, especially in China's ambition to peak carbon emissions by 2030 and achieve carbon neutrality by 2060. This research aims to identify and implement strategies that enhance the energy efficiency of rural residences, contributing to global low-carbon emissions and the Sustainable Development Goals. Problem statements. Objective: despite advancements in urban low-carbon building standards, rural dwellings still lag behind. The problem is twofold. Firstly, there is a lack of specific guidelines for low-carbon practices in rural buildings compared to their urban counterparts. Secondly, even when villagers wish to upgrade their homes, they face inadequate technological guidance and insulation materials. Our research objectives are to identify the unique criteria for low-carbon rural dwellings, determine the optimal insulation materials and thicknesses for walls and roofs, and propose actionable strategies for optimization. Specifically, we ask, what are the different criteria for low-carbon buildings in rural versus urban areas? What is the best insulation for wall and roof structures? And what is the optimal thickness for polystyrene insulation boards? Finally, what are the best recommendations for insulating structures to optimize both roof and wall designs? Conceptual framework. Our conceptual framework outlines the independent variables, dependent variables, and moderators guiding this research. We focus on identifying the characteristics of low-carbon practices in rural dwellings, with the optimized thickness of polystyrene insulation boards as a key independent. The dependent variables include the proposed optimized insulation structures for roof and wall designs. This framework serves as the backbone of our research, ensuring a systematic approach to finding solutions. Technology methodology. Our technology methodology involves a combination of on-site surveys, data collection, and optimization simulations. We conducted extensive fieldwork in Jianhe and Bailu villages, analyzing house types, design features, wall and roof characteristics, and insulation materials. Using advanced software, we simulated various insulation scenarios to determine the optimal materials and thicknesses. This rigorous approach ensures our recommendations are based on solid data and practical application. Goals. Scope. The goals of this research are to optimally obtain the best insulation materials and thicknesses for roof and wall structures in existing rural dwellings within the SuQian section of the Beijing-Hangzhou Grand Canal. Our scope is defined by these specific villages, focusing on the optimization of insulation practices by targeting these areas. We aim to create a blueprint for similar rural settlements looking to enhance their energy efficiency. Significance of mode. The significance of our research lies in its potential to enhance the living environments of rural residents, reduce energy consumption, and contribute to broader environmental sustainability goals. By implementing low-carbon optimizations, we address initial construction shortcomings and align with global sustainable development targets. Benefits to end users and society. For end users, the benefits are immediate and long-lasting. Enhanced thermal comfort, reduced energy consumption, and improved indoor air quality all contribute to a healthier, more sustainable lifestyle. Societal benefits include reduced greenhouse gas emissions, economic efficiency, and cultural preservation, ensuring rural areas remain vibrant and environmentally conscious. Commercialization potentials. And the commercialization potential of our research is substantial. With increasing global demand for sustainable building solutions and technological advancements in insulation materials, the market for optimized rural insulation is ripe for innovation. Supportive policies and regulations further enhance the viability of these solutions, making them attractive to consumers, policymakers, and investors alike. In conclusion, optimizing low-carbon practices in rural dwellings along the SuQian section of the Beijing-Hangzhou Grand Canal represents a significant step towards achieving broader sustainability goals. By identifying optimal insulation materials and thicknesses, and recognizing the commercialization potential, we pave the way for a more prosperous, strong, beautiful, and high-quality rural living environment. Thank you for joining us on this journey towards a more sustainable future.